Okay, so right now I'm going to show you how to find derivatives involving inverse trig functions. So here are the formulas, and so if you need to memorize these, you can memorize them, but I allow my students to write them on a little cheat sheet for exams. Okay, so the derivative of arc sine of u is u prime over the square root of 1 minus u squared. Or you could say it's 1 over the square root of 1 minus u squared times u prime, but it's the same thing. Okay, now one thing you probably need to know is that another way to write arc sine of u is to use this notation. Okay, so that's another way to represent arc sine of u, sine to the -1 power of u. Now, I'm going to go ahead and just use the arc notation, but just be aware that you might see these functions written this way in other texts. So, okay, so here's the formulas. Okay, so you can read the formulas, and there's a formula for the arc function of each trig function: arc sine, arc cosecant, arc cosine, arc secant, arc tangent, and arc cotangent. Now, if you need a refresher on what these functions are and what they're about and where they come from, then you can research that. And because in this section, all I'm going to do is let you know how to find these derivatives. And actually, you can check my calculus videos, and there's a full lecture on inverse trig functions. Okay, now what have we got here? Let's look down here. Here we have the arc sine of 2x. So I want to find the derivative of arc sine of 2x. Okay, now I need to know what u is. Let's see, there's arc sine. So here's the formula for arc sine right here, or I'm sorry, the derivative of arc sine. There's the formula for the derivative of arc sine. So now I just have to figure out what is u. Well, u is 2x. So u is 2x. So what I'm going to do is I'm going to have 1 over the square root of 1 minus u squared. I'm using this formula here. So I have 1 over the square root of 1 minus u squared. Okay, and remember u is the 2x, so that would give me square root of 1 minus 4x squared. So in the denominator, I'm going to have the square root of 1 minus 4x squared. And then I have to multiply that by the derivative of u, and the derivative of 2x is 2. So I just have 2 over square root of 1 minus 4x squared. So you can see I did this as if the formula said it's 1 over all of this times u prime. But whether you do it that way or just put u prime on top and then put this radical on bottom, it's the same thing. So you end up with y prime is 2 over the square root of 1 minus 4 squared. Now I'm going to do an arctangent example here. And so an arctangent, so now I have y equals arctangent of x squared. Okay, so on that one, let's see, arctangent of x squared. Where's my arctan? Here's arctan right here. So arctan would be u prime over 1 plus u squared, or if you do it my way, 1 over 1 plus u squared times u prime. So let's do 1 over 1 plus u squared times u prime. Well, now in this case, I know my u is x squared. Okay, so u is x squared. So if I do 1 over 1 plus u squared, that would be 1 over 1 plus x squared squared, which would give me 1 plus x to the 4th in the denominator here. And then I multiply that by the derivative of x squared. So you've got to multiply by the derivative of x squared because that's your u prime. So multiply it by the derivative of that, and the derivative of x squared is 2x. So if we multiply this function here by 2x, we just get 2x over 1 plus x to the fourth. And again, if you prefer, you can just say u prime, which is 2x right here, over 1 plus u squared. So over 1 plus x squared squared, which is 1 plus x to the fourth. Okay, now the next one here is actually an arcsecant function. So I have y equals the arcsecant of natural log of x. So let me find that one. That would be right here. Okay, so that one is right here. Now, so this one, I actually am going to use the concept of 1 over all of this times u prime this time. So now let's talk about the 1 over. So this is going to be 1 over the absolute value of u times the square root of u squared minus 1. Now in this example, u is actually equal to natural log of x, because natural log of x is the argument of my arcsecant function. So now, I'm going to have 1 over the absolute value of u, and remember the absolute value of u is natural log of x, so that'd be 1 over the absolute value of natural log of x, and then times the square root of natural log of x quantity squared. Okay, make sure you put natural log of x in parentheses, because if you don't, you might have it like natural log of the argument x squared, but that's not the same as natural log quantity squared. So it's natural log squared, quantity squared, and then minus 1. And then you have to multiply by u prime. And u prime would simply be the derivative of natural log of x. And we know that's 1 over x. So now, I'm not going to put 1 over x in the numerator, because I know that if I put 1 over x in the numerator, that would be the same as multiplying this by 1 over x. So I'm just going to leave the x in the denominator. And so I'll get, the denominator will have x times the absolute value of natural log of x times the square root of natural log of x quantity squared minus 1. And so that would be your derivative of that particular function. Now, I didn't do derivatives for all of these, but I figure if you've got the formulas for these others, then you certainly can apply the formulas similar to how I applied the formulas for these 3 examples that I did. So that's all I've going to talk about here as far as the derivative of these inverse trig functions. And I'm going to do another video next on derivatives of hyperbolic functions.